Position.
Okay. So let's start. So hello everyone. Welcome to my third lecture. In this lecture, I'm gonna introduce how to use AICON to calculate the transport properties, and also how to use bootstrap tool to calculate transport properties. So this presentation is just some kind of show which tell you how to do it. You can download them and try it by yourselves. Okay. So first, about AICON. Yeah, I give the link for the software. It's open source, so you can download and install it, and it's totally free. The AICON relies on several external programs to achieve its functions, such as SciPy, PyMatching. The installation of AICON itself is very easy. You can use pipe and just write pipe install AICON, or you download the source package and install it. Use the Python setup install. It shouldn't have any problems. If it has, I think it's the main problems may comes from installing and configuring these reliable libraries correctly. So before install AICON, this program should be installed first. The formal tool is used to do the mathematical calculation and processing the data.
Oh, sorry, we still see only first slide, 75. We still see 71 slide.
Wait a moment.
Section 4.
Okay, so you didn't see this?
Yes.
Let me try. Can you see it now?
No. No full screen. No full screen. Again. Try again. Try again.
Okay.
Wait.
Everything is okay?
Нет. No.
No? Holy shit. Okay. Interesting.
Try share all screen.
So,
Yes. Yes, and full screen. Yes, no, it's okay. Yes.
Okay. 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 Yeah. So please download AICON from this using this link. And you can I mean, the installation of AICON is very easy. So you either use pipe install AICON or from its software package, Python setup install. So the installation shouldn't have a problem. So the main problem may come from those reliable libraries. So before installing AICON, you should install this Dizайн package first and successfully. Normal tool is used to do mathematical calculation. The last three is for the automatic working control. So this picture shows the process of using AICON to calculate electronic transport properties. Before calling AICON, you should finish this first principle calculations first. As we see, at least 13 calculations need to run. So after this first principle calculation finished, the results have to be collected into the corresponding directories, which the name should be exactly as this list shows. Basically, you need a 3-band structure calculation, which calculated at different volume. Then effective mass at CBM or VBM, all the effective mass for second band if it exists, the dielectric constant, and the elastic constant. Well, you can use AICON minus H to show the help information. I think I have give a clear explanation under this operation commander. So, but maybe there is one argument I may need to introduced more clearly. So this minus M mode argument, it selects the mode for electric conductivity calculation. For the electronic transport properties, it has two modes: standard mode or the doping mode. In standard mode, properties are calculated as a function of temperature and chemical potential. Where chemical potential starts counting from the middle of the band gap till the 1 electrovoltage above, with a step of 2 milli-electrovoltage. Where in doping mode, properties are calculated as a function of temperature and the doping concentration. So this doping mode is better to be used to compare with experimental results. And yeah, here I show the example of using AICON on the standard and doping mode respectively. It's the command is very simple. So first, you should specify minus ELEC to specify you are doing the electronic transport property calculation. Then specify the mode, either standard or doping, followed by the temperature range you are interested in. Also, for doping mode, you might need to specify the carrier concentration you are interested. So like this. See, this is using AICON by the command line way. But AICON's function can also be called from the Python script, as this picture shows. You see, just serialize, and it can be easily called by Python. I added this script into the installation package, so you can find it there. And so after the calculation finished, there was, see, this is the working directory. You have you have each directory for contains the the first principle calculation, and after it finished, there will be several output files, include one parameter file and several Excel file. So in this parameter file, it contains key parameters extracted from first principle calculations, such as effective mass for CBM and VBM, band gap, dielectric constant, etc., etc. Well, for this Excel file, they contain the transport coefficient calculated. Since I use AICON, all the data calculated will first stored as pandas data frame object. So actually, this data can be saved as any file format as long as the pandas support. So users can change it according to their needs. Let's see an example of this resulting file. Can you see my screen?
Yes, yes.
Okay, so this is an example of the result which calculated under doping mode. You see, first column is temperature, second column is doping concentration the users specified, and the third column is also the concentration, but just different in the unit. The following several columns are the transport coefficient calculated, and the last four columns are the relaxation time. So the total relaxation time, acoustic contribution, optic phono contribution, ionized impurity contribution. So very clear. You can understand it when you saw this. Also, this is the resulting file, which is calculated on the standard mode. It's almost the same as the which on doping mode, except the second column is the chemical potential mu. You see, and this concentration is concentration corresponding to this chemical potential. So as I talked, the chemical potential is counted from the middle of the band gap until the 1 electrovolt higher. So yeah, okay. I think yeah, this is the resulting file for the electronic transport property calculation. And next is the calculation for of lead thermal conductivity. So this picture shows the process for calculating it. We start from relaxed. We start from relaxed structures, then calculate its phonon spectrum and the Grayson parameters with DFPT or finite displacement method by phonoplay plus WASP. Then get the resulting file, band YAM and Grayson YAM. Use these two files as input together with the postcard file of AICON as input for AICON, so we can get the lead thermal conductivity values. During this process, you might need to run the AICON twice. See, this is AICON minus phonon for the phono property calculation. The first time you run AICON is for getting the highest symmetry path, which you need this high symmetry path as an input of phonopi to calculate the phonospectrum and the Grayson parameter. And the second time is calculate the kappa value. You see, the command is quite simple and clear. So you just need to specify the temperature you want to calculate. That's all. And after the calculation finished, you will find you will find the result in this kappa Excel file. So let's see how it looks like. So yeah, this is a kappa file. So first column is temperature, and the second column is kappa, contains the kappa. And all the other columns are the phono relaxation time calculated for three acoustic phono branch and one studio optic phono branches. That's all. Okay. So yeah. So as I talked previously, in order to before calling icon, you need to finish this first principle calculation first. These calculations follow some order, and they have different complexity and takes different time. So it could be painful to manage the whole workflow, especially if you are doing high surface screen work. That's why I also implemented automatic workflow control tools based on the atomic and the fireworks. The users I designed a workflow specified for the icons calculation. So the users only need to submit the job once, and then the program will take care of the work automatically. Let me show you how to achieve this. Okay, can you see my screen? Yeah.
Yes, yes.
Okay, so yeah, this is the file is named create workflow. I also put this file in my in the installation package, and so the main body of it includes two parts. The first part is the setting of first principle calculation parameters. This is for me, I use WASP. So this is for the Inca setting for WASP. Here you should give all the necessary Inca parameters for the involved calculation, such as the structure relaxation, static calculation, band structure calculation, dielectric, elastic constant calculation. So this part of content should be changed every time you submit the job for the different compounds, of course. But then the second part is some kind of configuration for your database. So I introduced the previous that you should install MongoDB database, and this is configuration information of your database, and this part of content just need to be configured once and keep fixed in the following calculations. So by doing this, I try to make the user focus only on the material science problems, and so save a lot of time to take care of the boring, workflow control I'll copy and move the files. Yes, this as long as you have set this file, this create workflow file correctly. So you just need to run this script, and your work will be submitted to the database, and then the file work will automatically extract the jobs and run it on your supercomputers. Yeah, so this is a general way to use icon, and I want to okay. So now I want to show you how to deal with data calculated from icon. Okay. So this first part is running icon to calculate the electronic transport properties from the Python script I have shown you previously. So you just this several lines. And after, suppose this calculation has finished, and now you get the those Excel files. So you want to visualize the results. First step, you need to import necessary package such as NumPy, Pandas, Matplotlib, and then you can read the resulting file. So it's quite easy to read using the Pandas like this, and then okay, so here you show I show the reading the files already been reading. Be right. It's a calculation running under the standard mode. So this is the result. There are 7,500 lines, and now you can we can split the data according to the temperature. Yeah, and then extract the transport properties such as carrier concentration, electronic thermal conductivity, power factor. And now we plot the power factor. So with the help of the matplotlib, you can you can, I think there are a lot of freedom you can it gives you to plot satisfied figures. This is just an example, and so here I calculated the power factor as a function of the chemical function of carrier concentration within the temperature range from 300 Kelvin to 1000 Kelvin, as you see. And so then after you finish the less thermal conductivity calculation, you still read into the Kappa file and show the results. So for now, you have the power factor and less thermal conductivity. You can calculate the figure of merit as this part of the code shows. And now plot it. The final result, it looks like this. So yeah, so from this figure you can see for this compound, its maximum figure of merit can be higher than 1 in the high temperature range. So this compound is promising thermoelectric materials, promising p-type thermoelectric materials. So yeah, this I think I have give you a detailed introduction about how to run icon from the beginning and how to deal with data using Python. You can see it's very easy with the help of all kinds of Python tools. Also, AICON is open source software, so you can add the function you want based on the code I write. Okay. So next, the last section. I want to show you how to use Bootstrap 2 because this software is also very popular for calculating the transport properties. So what's Bootstrap? Bootstrap is a modern implementation of the most foreign interpolation algorithm for electronic bands that form the basis of the original Bootstrap code. So one of the most typical use is the calculation of thermoelectric transport coefficient as a function of temperature and chemical potential in the reggae bed picture. Here, I need to emphasize that Bootstrap 2 use a constant relaxing time approximation. So it assumes that the electronic relaxing time is not changed with the band index and the wave vector. This, however, will cause a problem for some results of Bootstrap, such as the electric conductivity or the electronic thermoconductivity. So they are actually not the direct results we want, because all their data include the relaxation time implicitly. That's why Bootstrap calculation is much faster, but it also means that users need to get this electronic relaxation time from other methods. Here I list the homepage link and the two papers which introduced its theory and utility. Since Bootstrap being published, there has been a lot of high throughput work using it to screen thermoelectric materials. The largest scale one is this work. This project is a part of the materials project database. The use Bootstrap calculated nearly 50,000 compounds transport coefficient. So this data are open source and people can check and download them. The use of the installation of the Bootstrap is also very simple. The dependent package is almost the same as that for AICON. You can install it either using pipe or from its source package. Same for AICON. This is the workflow of Bootstrap 2. To start from the DFT calculated wave vector, band energy, and the electron velocity. First, do the interpolation work to get the band energy on an extremely dense mesh. Then do the integral work to obtain the generalized transport coefficient. So there are also other functions such as plotting the Fermi surface and the plot band. Users who are interested in these functions can read its manuals. So here I show you how to use Bootstrap in command line way. So first step, you can get the help information by type Bootstrap 2 -h, or Bootstrap 2 interpolate -h to get the information of interpolation functions. Second, interpolating the band energies. The required input files are WASP run and IBZBKT if you are using WASP to the DFT calculation. Then run this command line. So there are only several variables need to be specified. For example, this -o specifies the output file name. this lowercase and uppercase e specifies the energy window around the Fermi level, in which the band in which the band near the Fermi level are taken into consideration. And the unit of the energy is the Hartree. Also, this minus m specifies the multiplying factor for the number of the irreducible key points in the interpolatation. So here 10 means the final interpolated meshes is 10 times denser than that existed in the ABZ-PKT files. The output file is point.bt2 files. This file is just an XZ compressed JSON document, which can be visualized and manipulated using a multitude of tools and libraries. Usually, users just need to treat this file as a black box. Third step, computing the transport coefficient. The input file as an interpolation file from the last step. Then you type the command line as this. Here, minus p specifies the name of output file, then followed by the input file name, and also the temperature range you want to calculate. The output file, including the point BTG file, the count tensor, Hall tensor, and the point trace file. The last three files are closely following the format defined by the original bootstrap. So they can be visualized by any text editor, loaded into any data processing code, or plot with any software you like. So this table lists the first column of the first column in the trace file. It's introduced the name of each column and its unit. So next, I'm going to show you how to call bootstrap and analyzing its result from Python script. So yeah, well, bootstrap has its own Python interface, but I personally like to use the interface written implemented in the PyMath because I think this interface is more convenient to use, and also with PyMath you can use many powerful tools powerful tools to analysis of the plot of the data. So first step, import the necessary package, and then load the DFT data, which you only need these last one wires. And now we can do the interpolate work. So use the command. The sentence is this. So it's the argument you need to set is the same as that in command line. So you specify the multiply factor, the energy range, and also the name of the result file. And here I already finished this calculation. So I just load the existing result file, and after you run the successfully, you can use the qualitating file interesting one. For example, a computer and structure and the dimension class. So here, you take the structure, show it So yeah, this is the fundamental structure, which is obtained from the interpolated band with mesh. But actually, you can have this structure is actually by mass directly, and it's almost the same. And you can also get, if you are interested in some specific paths, you can like this. So those are the paths you want to see, and the plot just along this path. And okay, now you want to calculate the transport properties. So basically, you can compute them with respect to the chemical potential and specific doping level. Well, in this function, you can calculate the gather. So so first specify the interpolation data, and then specify the temperature you are interested, and then the doping concentration you want to calculate. And if this calculation finished, you can get the result and plot the figure. So for now, okay. For now, let's plot the data. So suppose I want to see the electric conductivity with respect to the chemical potential, and you can plot as this. Just use this command, and yeah, here is the picture. So the electric conductivity changes with chemical potential at different temperature. Also, you can plot the subcoefficient the same, select the temperature you want, like this. You can also plot the figure transport properties with respect to the chemical potential. So the commander is like this, and yeah, this is the result. And finally, you can plot the power factor. See, so with the help of parameter all this calculation and plotting, analyzing is quite easier. So, well, I think that's all what I want to show you in this part of lecture. Thanks for your listening. Questions?
Yeah, question in chat. See in chat.
Okay. Python plus WASP plus AICON, we make it all mobility and Kubernetes for thousands of. So what keeps us from using machine learning on this data frame to predict all the properties by just type crystal structure and position and type atoms in the cell? Yeah, this is a good question. What keeps us from using machine learning? Well, this is how to say, how to explain this to you. So I think first is the amount of the data. Yeah. So for effective machine learning model, you need a lot of data. For now, so The problem is how do you get this data? So, for example, if you try to learn the results calculated by AICON, then I think the most as I showed in my in the slides, the most of the calculation is not spent on AICON's calculation. It's spent on the calculation of those key parameters such as dielectric constant or elastic constant. So suppose if you have this data, then calling AICON to calculate the transport property just take you several minutes. So for this situation, why we need the machine learning model? And in another situation, if you want to learn a more complex model, such as those totally from the first principle calculation, then you need to you need to calculate those mobility. I mean, using as I showed in my last in the previous section, you need to calculate the totally first principle calculation is quite time consuming. So you won't get many data for training your model, machine learning model. This is the one. So yes, this is the one problem. And the second problem is about the transport property itself. So here I just show you the transport property is as a scalar value, but actually almost all the transport property are a tensor value. So if you want to study to use machine learning to study this tensor value, the model would be complex. I think for now, I read some papers about this using this message passing network with some specific descriptor. It's not just types of crystal structure and positions. And if you just use this information, you can't get a very good machine learning model for predict the transport properties. There are many other things you need to include. This is a very hot topic in this transport property field. So yes, if you are interested, you can read. I think there are several papers published last year and this year, so you can read them. And the second problem is it possible to get IPR file estimation? Oh, okay, yes, of course. If you need, I can upload all my Jupyter notebook files. Yeah, it's totally okay.
Any question? Very interesting. Yes, you're right. So all information you can find. Tao, are you sending this your slide to email to our students? It's possible.
Send by email.
Yes.
It's okay. It's okay, but also I want to attach those Jupyter notebook files. So maybe you can send them together.
Yes. Also you can send a link to this website, which you show.
This is in my personal laptop. So
it's your personal file. Okay.
Yes. I will send these files to you.
Yes, I understand. Okay. Any questions? So more information you can find in Tao article and also in our website uspech.team.org about ICON and about article about this topic. Так, Алексей, typing question. Homework.
Homework. Well, I think I didn't. You can just. I think you can just download my the icon and the bootstrap tool. Try to repeat the calculations in the example, in the examples. So familiar these two software. This is a homework.
Yes, and send these results to Tao email.
You can just compare. Yeah.
Because we need check homework Tao.
What? This is for some credit?
No, some credit, but some certificate.
Okay. I got it.
Okay, so you just need name student and just plus or minus of his homework and send Natalia or me. Okay, so guys, if you send your homework to Tao, please write your name, surname in English, and of course email in English. Or Chinese, if you want. If you know. Так, ребят, в общем, нужно будет скачать Icon и Bootstrap. Ой, не Bootstrap, Bootstrap 2, yes. Скачать Bootstrap 2 Icon, попробовать их запустить, и результат этого запуска, скрины экрана просто отправить презентацией или файлом Tao, и он просто посмотрит, получилось у вас или нет, поставит плюс или минус, зачет или не зачет. Составить список, отправить мне, либо Наталью, либо Аганову. Ну, я помогаю Артему Ромаевичу с администрированием всего этого процесса. Вот. Есть вопросы еще? Any question for me, for Tao? Да, я сижу из-под аккаунта Натальи Калинина, но это просто так создано. Меня зовут Илья Чепкасов. Я работаю у Аганова. Tao email. I think Tao sent